In an activity we did in class recently, we had a diagram like this, and we noticed that no matter how we manipulated the angles, there was always a relationship that existed between those angles. And so in this video, I want to kind of formalize those relationships. So in this table, in the Explore section of your notes, it's asking you to find each of these angle measures. So in the diagram, angle 1 is 80.18. There we go. Angle 2, 99.82. Angle 3, 80.18. And angle 4 is 99.82. And if I add angles 1 and 2 together, I get 180. If I add angles 2 and 3 together, I get 180. Angles 3 and 4 add up to 180, and angles 1 and 4 add up to 180. And what we've been measuring has been linear pairs of angles and vertical angles. And we've seen the vocabulary for linear pair before. When two lines intersect, the angles that are opposite each other are what we call vertical angles. Again, remember that we've seen the vocabulary for a linear pair before. Those are the adjacent angles, the angles that are next to each other, and the sides that they don't have in common are opposite rays, meaning they're on the same line going on opposite directions. So when two lines intersect, the angles that are on the same side of a line form a linear pair. It's asking us in the reflect problem 1 to name a pair of vertical angles and a linear pair of angles in our diagram from step A. So in your notes, you might want to copy that diagram down so that when we identify a pair of vertical angles and we identify a pair of linear pair of angles, you're not kind of looking at those numbers later and wondering what they referred to. In this diagram, remember the definition that our textbook gives us, that a pair of angles formed by intersecting lines that are opposite each other are vertical angles. What you'll often see me do in class when we're talking about vertical angles is I'll make an X with my arms, because that's what you're looking for, is the vertical angles will look like an X. Okay, so that would be angles 1 and 3 and angles 2 and 4. A linear pair of angles could be angle 1 and angle 2. And also the other 3 pairs of angles, excuse me, in that table, angles 2 and 3, angles 3 and 4, angles 4 and 1. Now we already know that the linear pair theorem tells us that if two angles form a linear pair, then they add up to 180 degrees. In Reflect question 2, they are asking us to make a conjecture, or an educated guess, about the measures of a pair of vertical angles. So we said here that angles 1 and 3 were both 80.18 and that 2 and 4 were both 99.82. So a reasonable educated guess about vertical angles is that vertical angles are congruent. And that is actually true, and we will prove that momentarily. So it's asking us in Reflect 3 to use the linear pair theorem to tell you what you know about the measures of angles that form a linear pair. I mentioned that earlier. Angles that form a linear pair are supplementary, or angles that form a linear pair have measures that add up to 180. So there it is. There's the vertical angle theorem. If two angles are vertical angles, then the angles are congruent. And we have done written proofs in 2-column and paragraph form. Another kind of proof is called a flowchart proof. And in a flow proof, we use boxes and arrows to show kind of our train of thought. So we're going to use a flow proof to prove the vertical angles theorem. In part A, they're asking us to complete the steps in order to plan the proof out. And then on the next screen, we'll actually do the proof. So in the steps for my proof, I'm going to start by talking about how, since angles 1 and 2 are a linear pair and angles 2 and 3 are a linear pair, I know that those angles are supplementary. That means that they add up to 180. And so by the transitive property, I can take those two equations and kind of smush them down to get that angle 1 plus angle 2 equals angle 2 plus angle 3. Remember that when you're doing a proof, keep your eye on the ball. Look at what you're trying to prove. We're trying to prove that angle 1 is congruent to angle 3. Right now, I have this equation where the measure of angle 1 and the measure of angle 3 are on the sides of the equation that I would want them to be, but oh, that angle 2 is just kind of putting a wrench in the works. But algebraically, since the measure of angle 2 is on both sides of the equation, we can subtract measure of angle 2 from both sides, and then use the definition of congruent. Okay, so we've kind of planned out the proof. Now let's actually complete the proof. Since I am trying to prove that if angles are vertical angles, then they're congruent, what I'm starting with is here. This is where I start. And since I'm trying to prove that those two angles are congruent, this will be where I end. Okay, so I'm starting by saying that angle 1 and angle 3 are vertical angles. That's given to me. And it's using the diagram to draw the conclusion that since angles 1 and 3 are vertical angles, it's fair that I can say that angles 1 and 2 are a linear pair, and that angles 2 and 3 are a linear pair, just based on the diagram. Earlier, we mentioned that when angles form a linear pair, that they will be supplementary. I'm going to abbreviate supplementary. You see it here as well. And since I'm saying the same thing in those two lines of reasoning, this line of reasoning, I hope that you would notice, is pretty much identical to this line of reasoning. I'm just talking about different angles in those two lines. So they're going to kind of mirror each other. So here my reason was linear pair theorem. Oh, here I need to fill in the reason. Guess what? It's linear pair theorem. Measure of angle 1 plus measure of angle 2 equals what because of the definition of supplementary angles? They add up to 180. Similar line of thinking down here, I'm saying that the measure of angle 2 plus the measure of angle 3 equals 180. And that is also the definition of supplementary angles. And then I'm taking those two thoughts and putting them together to get this equation. Notice how these arrows are kind of feeding into it. And I mentioned on the previous screen that that is the transitive property. And we also talked on the previous screen about how we can subtract angle 2 away, so that's the subtraction property. And then finally, if I know that their measures are equal, then I can say that the angles are congruent using the definition of congruence. So we're using these properties of vertical angles and linear pairs in order to find missing angle measures in our diagrams. So in example 1, part A, we're asked for the measure of angle 6. Notice their reasoning, because vertical angles are congruent, angle 6 will also equal 146. In part B, we're trying to find the measures of angles 5 and 7. We know that they will be congruent because they are also vertical angles. But it says from part A, I know that the measure of angle 6 is 146, and angles 5 and 6 form a linear pair. They are supplementary. So the measure of angle 5 will equal 180 minus 146, and that's 34. And the measure of angle 7 will also equal 34 because the measure of angle 7 also forms a linear pair with angle 6, or because it is a vertical angle with angle 5. Now we're bringing a little bit of algebra into the mix. In this problem 6, the measures of two vertical angles are given to us as 58 and 3x plus 34. We know that vertical angles are congruent, and congruent means that they are equal in measure. So you would set up the equation, 58 equals 3x plus 4. And then you just solve for x. Subtract the 4 from both sides, and I have 54 equal to 3x. Divide both sides by 3, and x is 18. Take a moment and work through the your turn number 7. In example 2, we are continuing to use a diagram and properties of linear pairs and vertical angles to find angle measures. In part A, they are talking you through the whole thing. So they asked for the measures of angles AFC and AFB. AFC and CFD, notice, form a linear pair. So I know that they're going to be supplementary. Based on the diagram, this little box here is telling us that that angle, CFD, is a 90-degree angle. So 180 minus 90 is 90, so I know that angle AFC also happens to be a right angle. Since I know AFC is 90 degrees, I know from the definition of complementary that AFB plus BFC will add up to 90 degrees. So 90 minus 50 is 40. So that's why the measure of angle AFB is 40. Part B, we're asked for measure of angles DFE and AFE. So since angles BFA and DFE are formed by two intersecting lines, and are opposite each other, the angles are vertical angles. Once again, if I were to highlight these two angles, you'd see that it looks like an X. That means they're formed by two intersecting lines. So I know that the angles are congruent. From part A, I know that AFB is 40 degrees, so that means that angle DFE is also 40 degrees. Since angles BFA and AFE form a linear pair, the angles are supplementary. And the sum of their measures is 180. So angle AFE is going to equal 180 minus the measure of angle BFA. So that's 180 minus 40, giving me an answer of 140. In part A of the previous screen, it's asking us to notice something about right angles AFC and CFD. Okay, so let's come back to that screen. In this example, my right angles that they're referring to are this one and this one. And what they're wanting you to notice is that those two right angles both had a measure of 90 degrees. So since they both have a measure of 90 degrees, we conjecture that all right angles are congruent. Finally, in this example, we're talking about these angles in words, and we want to make sure that you realize that since complementary angles add up to 90 degrees, if one of my complementary angles is x, its complement would be 90 minus x. Similarly, if I have two supplementary angles and one of them is x, the other one can be expressed as 180 minus x. So we're using that information to solve these word problems algebraically. It says that the measure of an angle is equal to the measure of its complement. So that means x will equal its complement being 90 minus x. Well, now that's just an algebra equation and we solve it. We start solving it by adding x to both sides. That gives us that 2x is equal to 90, so x is 45. So both angles are 45 degrees. In number 10, it says the measure of an angle, that's x, means equals, twice means 2 times the measure of its supplement. So remember, if one angle is x, its supplement is 180 minus x. And then again, once you have the equation down, you should be scot-free. That's algebra all the way. Distribute the 2, and you have x equal to 360 minus 2x. So your next step would be to add 2x to both sides and get 3x equal to 360. And when you divide both sides by 3, x is 120. Now this time the two angles aren't the same measure. So I know one of the angles is 120. And since they're supplementary, they have to add up to 180. So 180 minus 120, 60.